ladies and gentlemen, and welcome back to the AM4U stage on day 3 of the Formnext 2022. We go on in the last session, and it's called Deep Thought, and we want to tackle a topic that is quite important and gets even more important every year in additive manufacturing. I'm talking about the topic of sustainability, as it continues to be one of the central issues in the development of our industry. Together with really important representatives of our industry, we want to get into a deeper consideration with our Deep Thought block. The first speaker and an important guest on our AM4U stage is none other than Melissa Orme, Vice President of Boeing Additive Manufacturing. And she will be giving a keynote on the topic Additive Manufacturing as a sustainability driver. And I'm super excited to welcome her here on stage. Melissa, please come and join me. Melissa Orme, big applause, ladies and gentlemen.
Okay, sound check. Sounds good. Okay. Well, it's really great to be here. Thank you for having me. We will just go right in. I wanted to tell you a little bit about myself. I've actually been in the additive manufacturing space for about 3 decades. I began as a professor at the University of California, Irvine, where my research was focused on what we now call additive manufacturing. At that time, it was solid freeform fabrication or net form manufacturing. I moved into a startup after that. I was a supplier. I was the chief technology officer of Morph3D. And now I'm vice president leading all of additive at Boeing. That's polymer and metals, flight hardware, as well as research, development, and anything that helps the company with respect to additive. So, a little bit more about Boeing, in case you don't know. We have 20 AM sites worldwide in the United States, in the United Kingdom, Canada, Australia, and soon to be opening other places as well. You may not know, but we have over 70,000 additively manufactured parts flying in Boeing products, 70,000. Many of those are polymer. Some are wire DED. Many are powder bed fusion aluminum, a few tie electron beam. At Boeing, we do have a factory in the Pacific Northwest with the full end-to-end value stream for polymer as well as metal, and all of the post-processing capability as well. And finally, the digital integration. We have created what we call the Intelligence Center, which focuses on all things digital with respect to additive. This is our digital thread creation. For every step in the value chain, we're extracting data automatically, and we're archiving that in our data library, which resides in the cloud. And we have formatted that in an easy way for engineers to find, so that they can now do their, create their machine learning algorithms or their data-driven models or their hybrid, physics-based data-driven modeling, and feed that back into our value stream. So for stability, for optimization, and for basically, efficiency, making sure that we get it right the first time, and reducing that power consumption. So, at Boeing, people ask me, like, so how many parts are you printing? And sometimes people want to just print a part for the sake of printing a part. And we always want to make sure that, the parts that you choose add value. And I've separated that into 3 types of value. One is on the part level. And so we might be able to, make a part faster or cheaper or add functionality or increase performance or quality. Product value, then this is very important, where we can say, I don't want to optimize the part, I want to optimize the airplane or the helicopter or autonomous system or whatever our product is. And so we use additive manufacturing to change the architecture of the actual Boeing product, which in our case is things that fly. And then there's program value, and we have, that might be tooling, or it might be wind tunnel mock-ups, or it might be using additive manufacturing to get an award, right? Because of the additive content, because we're able to deliver faster, cheaper, and higher quality. So everything we do, has to reside there, and we're really focusing on that product value. Here's a few examples. I've shared some before, so I've consolidated on a single chart. The picture on the upper right, the first one, that's our MQ-25 autonomous refueling drone. It's quite large. It's fixed wing. And the first part on the lower left is the heat exchanger. And we've cut that in half so you can see all the fins inside. And it's quite big. It's built on a EOS M400 at the maximum, using all of the volume of the build, basically. The second picture on the lower left is our new product line. This is a fully 3D printed satellite. Its dimensions, are half of a meter, I would say, on all axes. And it's basically a new product line. We're doing this in collaboration with our partner Millennium Space Systems, although the 3D printed component, all the additive is Boeing invention, if you will. We found that we can reduce the lead time by 5 months and the cost by 30% by switching over to the additive solution. The third picture, that's the Chinook, high-intensity searchlight, and so that is in powder bed aluminum, also built on a EOS M400 to give you an idea of size. I'm quite proud of that part. It's been in service with the customer since 2019. I think it might be the first powder bed additive part on a helicopter, which has a quite intense vibe environment. It was redesigned to withstand that vibe environment, as well as salt, fog, sand, shock, acceleration, and so it's very sturdy and it's performing quite well. We've delivered 16 ship sets. And the last is the aperture cold plate. That's also on a 400, and that's a multifunctional part. It's a waveguide, a heat exchanger, and a structural component. So those are just some examples of some parts that we have basically already inserted onto programs. Currently, we have today, we have about 1,200 different parts in our manufacturing flow from somewhere in that value stream. I wanted to talk now about our Eco demonstrator. And if you're not familiar with the Boeing Eco demonstrator airplane, it's a series of airplanes that we use without passengers. We fly it. We test new technologies on it. And so it's called the Eco demonstrator because all of the new technologies have to do with sustainability. It's flown with a mix of sustainable aviation fuel. And just 2 months ago, 2 of our parts flew on it. The first is the Inconel bracket, which is shown on the right in the middle. And the lower one, that's me, so that you have a sense of scale. It's not a part that's this big, right? It's a part that's this big. And that's the APU exhaust duct. And so that was created with DED blown powder, and it's titanium. And it performed quite well. So we're quite excited about that technology, and that's something else that we're maturing within Boeing. So at Boeing, we're not, dedicated to one only technology, but whatever our applications are, we will try to make sure that we have the technology that's suitable for that, right? So different applications have different technologies. Powder bed fusion for some of those smaller parts, DED for some of the larger parts, and we're always open to looking at what's next. So Boeing, like many other companies, is committed to decarbonizing aviation, and we're committed by 2050 to be decarbonized flight, essentially. So these are our commitment numbers by 2025 for our operations. Cut greenhouse gases by 25%, water consumption and solid waste to landfill by 20%, energy use by 10%, and hazardous waste by 5% compared to 2017 levels. And so Boeing Additive Manufacturing, that's the group I lead. We call it BAM, Boeing Additive Manufacturing, all of additive within Boeing. We've committed to reducing the same things. But you'll notice there's no numbers there because we weren't sure, right? And we're still not. It depends on the application. So that's what I'm going to show you, basically, some of our first studies. So with additive manufacturing, there are many different facets of sustainability. And I've really broken it down into two large categories. And each of those have subcategories, of course. The first, which we call indirect, is the actual manufacturing process. So that's how much, what our sustainability trade is in our operations. And the second is the impact of the part produced. So people kind of forget about that part. I mean, if we are able to lightweight a part, then we need less fuel to propel it to where it needs to go. But it's not just lightweighting. If we're able to actually change the architecture of, say, an airplane, if we're able to make the wing smaller, it's going to have less drag. If we can remove those blisters on the underside because we've been able to architect the internal aspects smaller, then the airplane will have less drag. It'll use less fuel. I mean, that's a really big impact, a bigger impact than the difference in weights of the components inside, right? That became smaller. So that's very important. It's something that additive manufacturing offers that traditional manufacturing does not. That being said, I'm going to focus on the first part, the manufacturing process, because I have a case study to show you today. And in that case study, we haven't optimized the part. So in each case, the performance of the airplane is the same. And this is just another way to look at the same thing. We're going for zero impact. We have indirect, which is the operations, the extraction of the raw material from the earth, and the conversion of that to a principal material. The logistics, the production, the distribution, the storage, and the direct, which we're calling actually the performance of the airplane. So this is the value stream. For AM, so it starts with the raw material extraction and the raw material conversion to a principal material, and then that transport of that principal material to wherever we will print it, the fabrication process, post-processing, distribution to where it needs to go. Also, there's distribution and post-processing too that we take into account if we send coupons and we receive them, things like that. The performance and the recycling. And so we have this the cycle that you can see below. It's not 100% circular, but we have the design for additive clearly lets us design lightweight, optimized, smaller components. Production, we're able to recycle powder. And I should say, in the design aspect, we're really working to be smart in our designs and to design without support structures. I know that a lot of people are looking to machines, as the solution to remove support structures, but we're really working at Boeing to be smart in the design of components and design it knowing which way it's going to be built and to ensure that there's no support structures needed. And we have some really cool examples of that. Distribution, additive lets you print at point of use in certain cases. Use, reuse, and repair. We've found that some of our parts are more durable than traditional. For example, that MQ-25 heat exchanger, it survives beautifully on a vibe table where the brazed counterpart doesn't. It fails at the joins. So the additive component is actually more durable. It'll last longer. It won't need to be replaced. It won't be scrapped. And I think I've said everything else, the raw materials and recycling. So we created several life cycle assessments, and I have one that's cleared to talk about. We finished it less than a year, so that's pretty good time for Boeing. But I have a few more that are just finished, and I'm not able to show you those. But the one is a good example. So this is what we look at. We look at the energy consumed, the materials consumed, water consumed, hazardous waste to landfill, and total emissions of greenhouse gases. And we'll look at that in each of these aspects in the raw material extraction and conversion. So we've done this for both traditional manufacturing and additive manufacturing for the same part as a comparison. So you'll see in the first area there, the first segment that says raw material extraction and conversion, it also has ingot, right? And so that's for when we're basically using a hog out or casting or something. So we use this also for the traditional process. It has atomization if we're using a powder. It has wire if we're using a wire feed. So we're looking at all of that. And then the same in the manufacturing processes. What's the energy consumption? What are the emissions? What are the materials used? Water consumption, transportation in every aspect, from the raw material out of the earth to where it needs to be printed, to coupons going to a test house, to the part going to a heat treat facility. All the transportation to finally to putting it where it needs to go. The usage and the waste disposal. So this is the elements of the life cycle assessment that we've performed. And so our first case study that I can show you is the 787 aft galley support bracket. Now it's shown on the lower right, and so what we see is the as printed. It's a near net shape. This was done with tie wire, and so it has a little bit of machining, and the machined part is right next to it, right? And so this went into production on every 787 Dreamliner since 2017. There is this part and 6 others, so there's 7 different part numbers on the 787 since 2017. So we have data of the manufacturing process prior to additive and with additive, so we thought this would be a good case study to begin with. Because we didn't optimize it, there's no gain in performance of the airplane. Somebody's happy. All right. Okay, I expect that from all of you. I'm kidding. Right, okay. Okay, so this is the result. Okay, this is the big moment. No, okay, I'm kidding. So the blue here is the traditional, the reference for the traditional manufacturing. And in this case, the traditional was a hog out. So we had a block of titanium that was machined to make that part prior to 2017, right? And so that's represented by that blue line. The orange is the tie wire. And so you can see in total energy consumed, global emissions, solid waste to landfill, total hazardous material use, and water consumption were always 40% or less than that of the traditionally manufactured component. So this was a really great case study. And that was driven by the fact that the traditional case is a hog out. It's a big block of titanium. There's a lot of machining. There's a lot of scrap, mining a lot of material, transporting a lot of material. All of that outweighed the AM energy consumption. Typically, it's high. Argon gas shielding, it's not necessary traditionally, and the stress relief. But even with those things, the traditional used a lot more of our resources. We looked at other effects too, and some people call these secondary effects. I'd like to say they're also primary effects because they're related directly to human health as well as the planet health. We have human toxicity, carcinogenic and non-carcinogenic. It's pretty important, I think. Acidification of the earth, water depletion, global warming, land use, ionizing radiation, and many other aspects, as you can see. And so, again, the blue line is the traditional manufacturing, and the orange is our additively manufactured component. So you can see that in this case, additive manufacturing demonstrates reduced harmful environments and human impact. I think it's quite evident. But the question arises, will all additive manufacturing exhibit this sustainability benefit? No, right? So basically, if I'm, this was a really great use case. We had a large hog out of titanium. It took a lot of machine work. It resulted in a lot of scrap. However, if we're going to now say, let's additively manufacture a sheet metal bracket, okay? Well, that's going to use a lot of energy, a lot more than making a sheet metal bracket traditionally, right? And so that won't give you a good sustainability case. And there's things at Boeing that we're doing right now that I can't show you, but I know the answer, all right? And so, but I want to say, I don't think we would additively manufacture a sheet metal bracket anyway. If you go to that first chart of where does it add value, I don't think there's any place that would add value, right? Unless for some reason you can't get it from a supplier and you're stuck and you have to launch something tomorrow or something like that, right? In some extreme example. But typically what we find, so far at least, and we're still early, we've only completed 3 different parts of different modalities, different technologies, different types of parts. So far what we find is that those situations where additive manufacturing, sustainability aside, does not have a good business case, it's also going to have likely a pretty bad sustainability case, right? So just like in additive manufacturing in general, not thinking about sustainability, it's not the cure-all to every single part. There are times when you want to use it. And in that case, the same goes for sustainability. There are times, and a lot of times, when you're going to have a really positive sustainability trade. But there are times that you won't, right? And so what we're doing at Boeing is creating a strategy around when we will. And then really being honest and working to develop our operations such that we use additive as a sustainability driver in those cases. There are other opportunities as well. And so we're probably all familiar. A lot of people, first thing they talk about is recycling powder. Yeah, that's really important, and we can do even better by nesting a little more and so forth. But don't forget that it takes energy to recycle powder. People think that suddenly it's all free, right? We have to reatomize, we have to transport it, but it does have a benefit, and that's why we do it. Recycling of support structures is something that we're working on, but better yet is creating parts that don't need support structures, creating smart engineering. A lot of these things can work with smart engineering, and so that little part that I'm showing you, that's the Amos 10 command horn antenna. It was originally a heritage part that had, I don't remember the number of parts. There were we consolidated it and have now 57% of the parts. So we did a lot of part consolidation. It had the original one had a tuning set screw for the internal aperture. It had actually some tape, in between pieces for sealing. It was clumsy. So we redesigned it for additive, and it doesn't need any support structures. It's so robust, right? Because you don't have to touch it. All you have to do is machine the bottom interface for attaching it to the spacecraft. And it might look like a small little insignificant part, but it powers the electronics of the spacecraft. So if this thing fails, your mission fails, basically. It's an important part. Simulation guided builds. This is where we're really working with our intelligence center to reduce the number of physical iterations. I won't tell you that we get it right the first time every time, but we're getting better and better, and that's also very important for sustainability. Machine utilization, we're looking at the trades of multi-lasers and nesting for energy consumption per part, and something I'll be able to share at some point later. Post-processing optimization, nesting as many things as you can instead of doing things separately. And finally, using energy sources, sustainable energy sources in our operations. And we also have the opportunity for greenhouse gas reductions by printing at points of use. And this is something that we're actually doing at Boeing. So we've developed this, we call it secure print solution, where we have a build file that's vetted, and the whole end-to-end value stream is created within Boeing. And when it's robust and stable, we lock it down, we encrypt it, and we send it with secure print to a qualified supplier someplace on the globe. We've already worked with Germany, Singapore, Italy, several places in the United States, Australia. While it's printing, we can watch it being printed in real time. We're streaming data back. The operator doesn't see the machine instructions. It just goes straight to the machine. And we can basically specify how many times it's printed, what serial number machine it's printed on. And so it's also basically really important for security. But if we want parts at a certain point of use, where we need a spare or a repair or something, then this is a really nice way that we remove that carbon footprint from transportation. And additive manufacturing gives us the ability to consolidate parts that subtractive manufacturing doesn't. And I think this is the biggest benefit of additive manufacturing when thinking about sustainability. We have a situation at Boeing right now where we have a certain component where we have eliminated 40,000 parts on one vehicle due to additive. That's 40,000 things that aren't being fabricated and transported and assembled and checked for quality, right? This is a fantastic sustainability driver. And in fact, people are always asking me at Boeing, Melissa, how many parts are you printing? And I said, that's the wrong question. You have to ask me, how many parts am I eliminating? That's the right question. So the most sustainable part is no parts. While manufacturing it, it consumes no energy. It emits no harmful greenhouse gases. It consumes no hazardous materials, creates no waste to landfill. It's always repeatable and reliable, and it costs nothing. So this is what additives can do, what traditional cannot. And so finally, I want to leave you with a quote that means a lot to me. It's a Greek proverb. A society grows great when old men and women plant trees in whose shade they know they shall never sit. And so this is why we think about sustainability. It's not necessarily for ourselves, but it's for people who come after us. And it's the right thing to do. So with that, I will like to thank you.
Big applause, ladies and gentlemen, Melissa Orm. Melissa, great presentation. Thank you so much. Yeah, leave it first to you to ask questions. We have such a big audience here. There's one question. We do have a microphone today, so we should use that in order to let the people in the stream understand the question.
Well, thank you very much for your presentation. So at Boeing, obviously, you're using a lot of technologies that are on the market, but which technologies do you consider that are coming to market, if you can disclose, that could benefit of using these sustainable principles that you're using? So which technology you might see that on the future will help the sustainability?
Okay, that's really a good question. And so at Boeing, we are open to looking at any technology that serves that solves a problem for Boeing products, basically, that helps us somehow, that adds value. So it could be in new material development, bio-based materials for printing, for example. It could be an entirely new platform that nobody has thought of yet, that I can't even tell you what it is because we don't know, right? But we're continuously looking for new technologies. There's a lot. There's liquid jetting, for example. That's not very well developed. That might have a good sustainability trade. We don't know yet. But whatever's out there, we're going to examine it. And if it provides value to Boeing, if it's something that our business units need to help us with sustainability, and also, cost, performance, quality, schedule, then we'll definitely look at that.
Yeah, and my last question will be, obviously, because all these new technologies are related to startups, so do you have at Boeing any startup program so that startups worldwide can apply and get all the technology being deployed on a Boeing program?
So we do partner with a lot of companies and a lot of small companies too. We have a really broad research and development portfolio, and we already are working with a lot of startups. And we partner with Horizon X AI, which is an investment group for this purpose. And so, there's some companies even in this forum, that we have invested in and we consider partners and we're developing. Yeah.
Thank you.
You're welcome.
Let me ask also a question to you. You just mentioned whatever benefits the company and brings that forward.
And sustainability is benefit
I know what you
company.
mean. Don't get me wrong. But sometimes I ask a critical question. So considering your work, I know you have quite some targets. Is sustainability a part of your personal targets as head of additive manufacturing?
It is.
It is.
Yeah, a part of my personal
development targets, whatever you have.
Yeah.
So
it's definitely. I think from a personal point of view, we have to do something. We're at a point in the climate, where we're in trouble, and we have to work together. And big corporations like Boeing are committed, and I'm committed.
Very good.
Yeah.
You mentioned this part reduction, that possible part reduction of 40,000 parts, basically.
Yeah.
How many of them are already realized? So what is the progress on that topic? Because, it's the one part to identify them, and we heard some very interesting speeches on reducing parts and identifying parts. But what is about the realization of that topic?
I think, what we're doing right now is all the parts in flow right now, they're new parts. They're not taking, well, not all of them. We have some examples of that, but we have new designs, right? And they're all looking at consolidation over what would have been traditional. 40,000 parts is something that we're planning to print in 2023. The little command horn antenna, that had a lot of part reduction. That upper white bracket, I didn't show that. It's a different chart. But we have a lot of, basically every part, I think, has its consolidation. Maybe a traditional might have been, we would have node fittings on carbon fiber, and we've made that all additively, for example, on satellites. And so there will be a lot of part consolidation. This is something that's really big.
Any other question? Because I have so many. I could spend now 50 minutes just asking questions. I have another one that is more technical one. If we're talking about part reduction, that basically could mean that you combine parts and you are able to do so because you're using additive manufacturing. Right. Are there any of those combinations already in place or in planning?
Yeah.
Yeah?
Yeah.
Can you mention, if you're allowed?
That little command horn antenna that I said powers up the space, the satellite. That's a consolidation of, I'm counting, there must be at least a dozen parts or more from that part, from an old heritage to that one, right? So, yeah.
Personal feedback, what I really liked was the Eco demonstrator, because remember we discussed last time what is already in place and what is realized. This is really reality in place. If you have airplanes flying with 3D printed parts in it and in a heavy use, brings me back to my generic question that I have to ask all the time, Melissa, please apologize that. We are often talking about interior parts, and if we're talking about space, there are a lot of critical parts already printed in 3D printing. But of course, it's unmanned. We send it into space. Whatever happens there, don't get me wrong, but it's not critical for us.
It's a good place to start.
Yeah, absolutely. And this is why I highly appreciate that. But where's the status if it comes to major parts in the airplane? How close are we? This is always a question that's quite interesting for me.
Well, first of all, the Chinook helicopter has people in it. Of course, it's a searchlight that goes under it, so that's probably okay. The part that I showed you, that's has a structural load in the 787 since 2017. We call that a structural component.
Okay.
And it's already there, right?
So let's say we are super close, basically.
And now we have our first powder bed part will go into production in about 2 months. It's not a safety critical part. We're easing into that, baby steps, right?
Yeah, but anyway, it's highly appreciated. Let me round off this session. Melissa, thank you so much. We're seeing you later in the panel discussion again. It was a pleasure having you. Great presentation. Big applause. Melissa Orm, thank you so much. Yeah, ladies and gentlemen, before we come to the next topic, of course you will be delivered highlight block, but let me say the next topic is a little bit from the other side round, because we will tackle the question, how important is sustainability for mechanical engineering? So please stay tuned, enjoy our highlight block, and I will see you in 3.5 minutes.